Audible?
Yes, sir.
Okay, very good. Okay. I think we'll just wait, or if somebody can say that we are good to start, we can start. I'll start meanwhile trying to present, share my screen as well so that we can save time in that.
Hello, sir.
Hey, hello.
Yes, sir. We will be start within 1 or 2 minutes. Okay.
Okay, sure. You can see my screen, right?
Yes, sir.
Yes.
Yes.
So many are expected to join this. You can see 67 people, around 2 more is expected, is it?
Okay, sir. Good morning, everyone present in the today's session. On the behalf of a Smart India Hackathon team, I welcome Shri Krishna Kumarji from the Data Consultancy Services and all the candidates to the today's online training session. I am Ashish Sharma, your host for today's session. This session has been specially organized to help you understand the today's topic, which will support you in preparing better for the SIH 2025. We are honored to have with our expert trainer, Sri Krishna Kumarji, an industry professional with extensive experience in this domain. Thank you, sir, for joining and providing training to our candidates. Now, without further delay, I would like to invite our respected trainer, Sri Krishna Kumarji, to begin the session. Krishna sir, over to you now.
Hey, hello everyone. It's a privilege for me as well to attend this and share some experience with all of you. If time would have permitted, I would have got introduction from each of you, but I think in the interest of time, we'll move on. Uh, I will share my screen now. You are able to see my screen, right? Are you able to see my photo and a slide deck? Just check
Yes, sir.
for the
Yes,
screen
yes,
share.
yes, sir. We can see.
Okay, cool. So yeah, so request you all on be on mute if you have any questions. I think during the Q&A we will take. Uh, I'll just briefly introduce myself. I'm, as you said, Krishna Kumar. I work with Tata Consultancy Services. Nearly 25 plus years I've been with this company. I've started as a programmer in the Microsoft technology, Visual Basic, and so on, and then moved on to .NET based solutions, then moved on to Azure based solutions, and now in the process of learning AI, I will not call myself as an AI expert because AI has just come in. We are also starting to learn what is AI, LLMs, and so on, and how to use those in our day-to-day industry solutions. So that is about me. I'll not get into the projects which I worked on, but generally my experience is on e-commerce. As I said, .NET Stack, building portals, mobile apps, services. Then we moved on to the cloud platform. I also lead a Microsoft Center of Excellence team for TCS for the insurance vertical in UK. I'll cite some examples in the process of some projects we have done in the UK and so on, which will just in that attempt to give you some real case study experience sort of a thing, so that right you will be able to visualize how these concepts are applied in the industry. One has to say that when it comes to this software engineering and IT services, what you learn in college or what you practice in college and what you do in the industry is not much far away, or it is not different. Or in other words, I am actually a qualified electrical engineer. I am a BTech in electrical from one of the well-known colleges in Kerala. But if you look at electric, and then I worked in electrical technologies itself, on transformers and motors and so on in a factory in the environment in Apollo Tires before TCS. So there, what you learn and what you see practically, it is related, but then you will see a little difference. It's like virtual to physical type difference you will see. Wherein here the concepts are very closely knitted. So without conceptual knowledge, it is hard to move on and then do something else. So that is where I think you all have an edge, and you will be able to easily comprehend this and then adopt onto your day-to-day life. So with that, we will move on and then move to our session, specific context of our session. So basically, this is about building scalable architecture, scalable solution, and so on, right? So basically, I'll start with a slight background. So as I said, when we started working way in 2000s or 1998 time, right, we used to call those applications are monolith applications, right? Most of the applications used in the banks or the industry or are things like a thick client app like a VB6 or a .NET based Windows app working with a um, uh, business component, which we used to call it as COM or whatever, and then it used to connect to an Oracle database or SQL Server database, retrieve data, store data, and so on. That is how we have started our e-commerce era, right? And then we moved on, right? So those applications we typically call as monolith applications, And then we started moving on to solutions where we started distributing the applications, right? So if you look at this monolith applications, right? Monolith applications are systems which are generally running on, at that time, running on the single machine. So if you have, let's say, a UI based, form based application or a thick client application, then the application and its business component which interacts with the backend, or the data component which interacts with the database, is all running in your machine, in your laptop, right? Because the compute requirement was only that. And then it might be connecting to a database like a MS Access or a database sitting in your machine. That is how it was. Then later on, what happened? I think we started getting into situations where we wanted to access, more than one people in the team wanted to access the data. That is where the distribution concept started coming. So we have to move this database at least to a middle place or to a central place where many applications or the many clients can connect, right? That is where we started moving the database to another server or to a machine, right? Then what happened again then, so in that scenario itself, if you see, instead of one client connecting to a one database sitting in your machine, now we are talking about hundreds of client machines connecting to a database, right? So if you have a employee database, and if you have an application to manage the employee record, there may be 100 clerks which may be working, or agents which may be working, which may be editing the employee records of, let's say, government service. They all will be trying to save to the same database at that time, right? Because the database would be a central piece, and the table would be, many tables are common tables, and so on. And that was okay at that time, because the transactions was only that time. So basically we used to implement things like the acid properties or whatever, right, in a database level, wherein one will not override the other. Or if one agent has taken, let's say, an employee one's record, we will not allow that employee one's record to be accessed by another agent and edit at the same time. So this type of a small scenarios only was there at that time. And the challenge, it was a challenge at that time, but we were able to solve it using transaction management in the database. And so that, right, concurrency handling, transaction handling, you increase the number of connection pools to the database. At the server level you increase, and that will allow more clients to connect in, and it was working properly. Then again the situation started growing up. Then we started seeing, as more, let's say, if 100 agents become 200 agents at that time, then the load on the database is more than one people are accessing. Even though different employee records are accessed, more than one people are accessing the table at a time. So that results in some sort of locks, for example. At that time, that was one major challenge for the performance. So people, let's say, if you increase the load too much, you will start seeing exceptions coming onto the client machine, saying that this record is now held by somebody else. There is a lock available, and the performance or the queries used to get timeout, because logs are database way of handling data consistency and ACID properties, right? It will not allow you others to edit. So it will implement a lock and unlock it as it gets over, so that the others can edit. So that was the situation at that time. Then we started seeing scenarios where, right? So again, when I said database and application in one machine, then we have seen it is moving to database on another machine within the same network, right? Within the same intranet is what we have initially seen, which means within the same server or same server room or whatever. So the travel between the application to your database is very quick and connect. And obviously, we had these database connectors like ODBC or whatever, which used to connect. Then what we have seen is, we started seeing the concepts of data centers coming in, remotely sitting networks, right? So then straight away, these databases are shipped to another powerful data center sitting in another location, maybe in US or UK. So then again, the network used to be longer, But then the performance of the network started becoming bigger because of this, IPsec link and various other technologies, right? Satellite communication, internet that started coming in, and so on, right? That is where you started seeing applications like what you can roughly see on my screen. I'll put it in the screenplay mode. It's just an indicative architecture of a typical large system done in a monolith. So basically, if you look at, I'll talk mainly about insurance examples because I am from insurance. Uh, by the way, everybody, I'm audible and clear, right? Or do we need to talk slowly? Or is it
Yes, sir, you are clear.
okay? Because I wanted to talk more and give you more, so that's why little pace I have. So don't worry, we'll clarify as much as I can. So then, as I said, we started seeing distributed applications, right? So the server, client, maybe client server, or the web portal's code maybe is deployed in, let's say, one data center in India, the middle layer, or the database. Let's talk about database first, then we'll introduce the concept of the middle layer. Then the database may be sitting in somewhere else because of this network connectivity and so on. We started interacting, same experience people are more or less getting. In fact, some people will get better experience because of the server's capability and the network speed. So then that started demanding more challenging technologies wherein you can execute remote. So instead of directly connecting to a DB and running a SQL, we started seeing requirement where the real business logic itself, we don't want to run it in the client machine or in the client side. So we wanted people to shift their business logic to another layer, which itself is running on a totally different server. So that is a remote processing, called RPCs, web services, all that started coming, right? So basically then that resulted in the layering concept. So a single code base monolith has started becoming multi-layered now. We started seeing applications built with different layers. So your client side will be a web form or a thick client or a internet client, right? Like an HTML page with JavaScript and some, either using a .NET or Java, what is that, JSP or whatever at that time. So it's a client application. Client application only deals with what you do in the client, like the click of a button, the validation, and some minor things. So that, right, it don't have to go to the server always. So that minimum things is required in the client. But when you click a button called get employee details or search for employee, all it does is it has to give a call to a service or a function which runs on a powerful middle layer server. So that is where the business layer concept started coming, right? I'm sure you know all these things. That's why I'm not going into detail of the slides and then putting all these things. So then the business layer is nothing but a function which implements that get employee details. And this get employee details function will be called through a service protocol, either a web service or whatever, from your web page by click of that button through a JavaScript or whatever. That is how it is. So the advantage is the client is very processing only that one which runs on your browser or runs on your web server, and that actually passes the responsibility to a middle layer machine wherein all this data mapping, all those things happens, and the middle layer started doing that database connection further to get the backend data. So earlier, if you were connecting from the client to the database, now the middle layer is connecting to the database. So a lot of security aspects have started coming in because we don't want databases to be directly accessible from the client machines, right? That's not a that's not a great security practice. We want database to be totally isolated. We used to call things like demilitarized zone type of a thing. I'm introducing various terminologies. You can just note down these terminologies and do chat GPT or whatever. You will get a lot of info about it. So databases are typically hidden from the layers above. That's the general concepts we work on. we allow databases to be connected only from the middle layer machines, not from the client machines. So maybe the middle layer machines IP is allowed to connect to the DB, or only through that port number. For example, databases have specific port numbers. SQL Server has a specific port number like 23 or whatever. So that enhances security. So even if a hacker come to the front end, he can only hit till the front end and maximum to the middle layer. He cannot go further with that, because from there middle layer to the back end, it's another layer of a connection, another protocol, another technology, another instance. So you can see in this diagram, that's how this has been wired, right? So now what happens, you have your application client application built, and you have your client applications built, and you have your middleware built, right? Middleware is nothing but a set of functions. These functions may be exposed as either components if it is running on the same server, or as services if it is running elsewhere. Because if it is running elsewhere in another data center, the only connectivity you can have between your web server's data center and the middleware's database server is only HTTP or HTTPS, right? That is anyway you would have learned in the college, that the only connectivity available between two disconnected data center is only HTTP or HTTPS. That's a fundamental of this web services type architecture, microservices, all that works on that. So that is again isolation and safety. So that's just exposing. There is a way to develop a function and expose it as a web service, like, or a microservice, and that will be connectable from the front end layer. Likewise in each layers. So that is how it has gone. Then now what has started happened, now what has happened, I would just give you another example. So we were all talking about one functionality of an application, right? One particular functionality of an application, employee front end, employee details front end, where you can search employee, edit employee, insert employee, and create employee. What we call is CRUD, right? Create, read, update, and delete. So that imagine you have a small portal to do that. For that portal, imagine you have a web service or a microservice layer called employee microservice to do that. It will call this, and from there microservice or the web service, it will call the employee database sitting behind it. That's how a simple thing is, right? Now imagine in a complex scenario, employee is one domain, right? In an enterprise, in any enterprise, if you look at our simple people management thing, just with one employee domain, it won't work. It has to work with other domain objects like department, for example, or it has to work with other domain objects like the payroll, for example, for the salary. So every different functionality is what I am calling it as a domain. I'll also talk about little concepts on that. So with that high level, I'll move to the next slide. Before that, I just want to say that monolith applications are mainly one domain application, handles one functionality, front end, middle layer, and database, typically in one machine. We have stretched that and moved that to middle layer to different machine. First we moved the database to a different machine. Now we are even stretching that to multiple geographic locations data centers by moving the front end web server in one location, the middle layer sitting in US, and the third layer database sitting in somewhere else. And each are interconnected using protocols like web service or whatever, right? Now we are also saying that for achieving complex functionalities like in an insurance company or in a typical enterprise, we have to start working with different functionalities of that enterprise, like the finance, the HR, the employee details, or the other product side of what that company produces. So when it comes to HR, it is the employee details, department details. When it comes to finance, it is the salary, payroll, and all that. So that is where at a high level you can see in this diagram that one application front end may be interacting with multiple business layers or multiple domain layers. For example, if that employee search also has to search for a salary of a particular employee, then what he has to do is he has to also invoke a web service from the salary domain as well. And that in turn will go to the salary database and get it. We'll, with this minimum introduction to this concept, we'll move on to the next layer. We'll also talk about how that interchange happens and why it is important to allow different threads to work parallelly and all that, right? Yeah, with that we'll move on. So basically, right, yeah, so I think we are now talking about modernization context. I will not talk about the process side of it. So for example, modernization, transformation, these are all related to changing the architecture from a typical one monolith type of a thing to a modernized architecture where it can scale out. When you say scale out, as we said, we moved from machine to different machines to different locations. Even different locations, we will see how to scale further with the advent of cloud and things like that. So that is scale out architecture. Technical, yeah, all these other things are, and it is all about business agility. For example, right, as we said, one application may be calling different functionality. A different functionality may be running or owned by different departments, which they will have to change independently. We'll come to that. So basically, again, just to catch up on what we said, the second thing is what you have to look at, and that is what is happening today. For example, right, the first part is a very is ideal for very small applications wherein you try to do a small POC, or in a hackathon you may generate a small application using some tools like Windsurf or whatever. I mean, there are various tools, right? You may create a small web application in one machine, run the web server on the same machine, database on the same machine. And so when you run in a same machine, what is it? It is like a different processes hosting your different services, right? One process may be running the DB in a different port, another process may be running a web server, and so on. So that's the first scenario. And there, once you develop in your application, in your laptop and test it, then the way to scale that for a higher number of users is nothing but just move that particular piece of code or the set of components to a cloud based architecture. So when you move to a cloud based architecture, what happens? Cloud services will host that. For example, if it is a website or a services or a database, the capability from your laptop to cloud is way too different, because there you are able to scale that application. It is actually called elastic scalability. When you put something to cloud, the terminology is called elastic scalability, because you are able to exponentially increase the computing power of it. You know what is computing power? Nothing but CPU and RAM, right? There used to be a saying when I was in engineering college, also saying that, right? Compute is costly, storage is cheap, and that holds good even today. Even today, as we speak, you would have read the news about AI, Nvidia, and various things. If you look, Nvidia, etc., are very popular because the compute, because the compute and the specific chipset they are able to deliver for the AI workloads. Storage is not an issue. Terabytes, gigabytes, petabytes of storage are available, quite cheap as well. Even if your GB, hard disk, everything, still the cost of it having gone up more than 200 rupees, 300 rupees. Then the compute cost is very high. So why people go for cloud is simple: for the higher compute, so that you can deploy the application for like large number of users with some basic configuration. You can deploy that. There are various ways of deploying it. You can deploy the component as is in a site or whatever. There are hosting services, but there are new ways of hosting for elastic scalability, which is nothing but the container based way of doing it. So you can host in containers. You can then start putting it as containers on things like Kubernetes and etc. If anybody is not aware, just note down these terminologies, read through it. So Kubernetes, etc., cloud container services, wherein you can say my code has to run in, my code is packaged in a container. This container has to spin up 20 different instances at a time, and if more requests comes than 20 at a time, you spin up more automatically. So such configurations are available in the cloud. If possible, we'll briefly talk about it later. The second thing is the most important thing we are talking about in the context of the current session. So basically, imagine the previous diagram which I've shown, right? We have this. Yeah, so this type of an architecture very clumsy, and you can see lines all over the place, right? There is, when you have lines cross horizontal and vertical too much, what happens? It crisscrosses and it's not maintainable, right? You don't know at a time from where which service is called or which who is the consumer of that, right? That's the difficulty. So your diagram actually talks a lot about it. If possible, try to do as much as horizontal connections or vertical, sorry, as much as vertical connections, horizontal are also required, but keep it minimum. So when it come to large applications, which TCS type of companies like deal with, let's say insurance, the entire insurance company, there will be large applications, like there will be insurance policy applications, there will be claim applications, there will be many other solutions. Like as I said, every enterprise will have the HR solutions, the other things, and so on, right? The payment, finance, and so on. So every functionality is a domain. That is what people call as domain driven design. For example, right, rather than building one application for the entire insurance company, people will focus on specific domains and subdomains. So domain could be finance. In that, there will be subdomains for different finance applications, like the claims finance, like the people finance, right? The policy finance, and so on. So domain driven design is one way of modularizing and splitting your applications into different manageable pieces. And then you can see that, right, that middle box here, it actually shows you that, right, that instead of having one big application, like in legacy, you break it down to different boxes, right? When you break it down, and then even you break it further. So when you break it to boxes, you will have the question, right? So which layer I am breaking, right? That is a good question to have. Will come. That is what I wanted to explain you in the coming slide. So here, little bit of theory as well is required, because we always, as I said, work based on certain fundamentals, right? I will briefly touch upon you here. If you see, right, this is a typical insurance company's high level architecture, right? You can see on the extreme left what are the key domains. Domains are nothing but, again, you think it as a department. For example, we have the quotation department for the new policy sales. We have the product, which is nothing but the policy itself. Then we have the enrollments policy. Yeah. The main thing is claim, finance, codes, new business or codes, and the policy, which is product. You only think about it. Then if you look at the next layer, right? So basically, you can imagine the leftmost maybe like a website or a portal. So there will be a portal for the quotations for buying the policy. There will be a portal for raising the claim. There will be a portal for settling the finance. There will be a portal for you to see your policy details, download the details, renew it, for example, like a vehicle insurance and so on, right? That's exactly this. Then as an architect or as a designer, how will you do the development? So basically, right, basically what happens, you will start looking to the right side of it, and then you will start in. So the right side, as you go, they are different layers, right? Different layers, and you will start visualizing which layer need to be there at each point, right? What level of abstraction is required, and so on. So at a high level, again, if you look at it, so leftmost is the portal, you imagine. Then the second to the left is product management, quote app, etc. You imagine they are the services side of it. So they are the business layer or the functionality you will write. So it will have, say, create quotation, read quotation, update quotation, or renew policy. Such functionalities are there. Again, you can see it is not just put it as one service or microservice layer. It is put as different sub You can see the dotted lines there, right? So you know why that is again layered it into internally small module is because you want to group it. So if you look at TCS, or if you TCS, if you look at and look at this architecture, right? If you look at TCS, we have different verticals. So we have insurance vertical from where I am part of. Somebody else may come from a automobile vertical. So again, when we deploy insurance web portal and insurance services, we will be owning it. The automobile part, he will be owning it. So that is why it is segregation of responsibility, segregation of ownership, plus the expertise as well. Because I have the expertise, I know what is required for the product management or the quota. But somebody else have to come in for the enrollment because I don't know that functionality. So that is how you typically break down. So every dotted box will be grouping of the functionality. Don't worry about the gateway layer, we'll talk about it. Then you go further to the right. There, yes, further broken down into subdomain services. So micro apps are domain. So if you see micro apps and the candidate apps are sort of a domain. For each domain, there will be one portal, there will be one service or an app, what they call as. Further, you have to break it down, isn't it? Because if you look at a product management, you will have to break it down to further subdomains. There are so many capabilities required to build a product. I think this example given here is a health insurance example, which all of you can easily relate. I'm sure all of you or your parents or your friends will surely have health insurance if you look at it. A renewal every day is required. You will go to an hospital and do the claim. You will also do settlement of it. You will also have to buy new. Many people who doesn't have to buy. So that is where the quotation and all those things comes. And once you buy, after 10 days, you will get the policy document, which is where the policy admin service, etc. coming. When you buy, the pricing will be listed there. When you say you have your parents 45 years wage, so on the pricing. So further, if you see each of those pentagon or whatever shape it is, they are subdomain functionalities. It is nothing but a set of functions again. It will say, let's say if you look at price, calculate pricing, it will have two functions called calculate the price or calculate the renewal price. That's all what it is. But they follow certain design principles, which is written high level here. I will also show you a slide. So each of this follow things like domain driven and bounded context design. DDDD it is called, or BDD it is called sometimes. It is nothing but every domain, let's say every subdomain called calculate pricing. This will only handle the pricing part of it. It will not handle anything else, like it will not have another function called get employee details or something there. No, that will be in some other domain. So clear boundary, clear isolation, and that is what independently deployable also. For example, if you are only dealing with pricing as my department, I know what to do, I know what to change, I can deploy without asking anybody. If you have shared functionality, you have to also get approval from the accounts department or the employee department, which is not a good design. So these are scalable ways of doing it. So you can also see there are two, important concepts written on the blue. One is called solid principles and dependency injection. So the solid principle, right? For example, this allows me to just open another PPT. Yeah. Uh, the last the I'll take through some of this theory in next 15-20 minutes, and I'll also explain using a case study. So basically, right, I also, this is why I said, when you are an IT engineer, the correlation between what you learned in college, what you practice in theory, and direct application I can see in the industry. So basically, right, uh, see, this I'm not going to go through. I'm sure you're all much better than me in this, because I haven't learned this through academia. This, when I was in electrical engineering in 1996, I learned through my work in TCS. So you are an expert of it. I'm only showing this to brush up this. why it is important is right. Why it is important is these are all functionalities. I mean, these are all concepts which takes us back to the olden days of OOPS concept. So if you talk about each of this pattern here, right, it always goes to the patterns of object-oriented concepts like the abstraction, the polymorphism, inheritance, and so on and so forth. Right? The interface concept in C++ and so on and so forth. All these are related to that. So, so what I'm trying to say is right. Yeah. So basically, there are various or patterns which are relevant. I will just take you through this. This is too much of theory. I don't want to really talk about it, but I'll summarize it for you. Okay. And I want to land into this, but before that, I'll summarize it for you. So basically, again, as I said, we started navigating into this during the talk around solid principles, domain driven design, and so on, right? Just solid principles. If you, I will just briefly open solid and we'll come back to this. So solid principles is nothing but too many slides and less time, so I have to really navigate for it. Okay, I think I can talk about solid principles straight away. Okay, that will be much easier than navigating through the slides. Mm, yeah. Mm. So basically, there are. Let me just give one more attempt because it will be easy to explain to all of you. Okay, fine. We will not waste time on that. Okay. I thought we had some slides on it. That's okay. So basically, right, we started from here. I'll just go back to the from where we jumped. So we started from the solid principles and dependency injection. So these are some of the key patterns which are followed. I'll tell you. So when you break down a domain into subdomains, and the subdomains are accessed from the layers above, right? We have to ensure certain disciplines in developing this. Then only these layer will be scaled. The biggest functional, for example, if somebody is clicking a button to get a quotation from the website, it all the way comes into this layer, and this is where the maximum time is spent for that particular response, right? So you're saying create a policy, get a quotation. So what happens? It will come here, it will validate your personal details, it will. So here more than one subdomain concepts will component will run, and finally it will do the calculate pricing. While doing that, it may read or write into the database. That's all part of this subdomain services which runs. So basically, what happens is maximum time is spent in that layer. That is where we have to ensure that this layer is properly scaled up. The service layer is properly scaled up. We generally use a concept where the client layer is kept very thin. So in the browser, especially very thin, you can run something in the JavaScript if possible, or using tools like Node.js nowadays. Directly hit onto the server. Let the server process, because server will be on a cloud or on a larger machine where it can afford multiple compute. Let it do parallel processing if possible, asynchronous processing if possible. You understand what I'm saying? Because when you get a create code request, right, it may have to do two, three things in parallel. One is it may have to check your your address by calling, let's say, a government address service, or it may have to call the Aadhaar service if it is in India, and get the confirmation that the Aadhaar, the what do you call, your Aadhaar is genuine, right? So many such things are required to ensure that you are issued a policy, right? You cannot be issued a policy without checking your demographics and your authentic, if you are an authentic person or not. That one it will check by calling an Aadhaar service. Parallelly, it will start putting your details onto the database, trying to work out a price for you. So, in fact, these two can work parallelly, isn't it? You don't need to wait for the Aadhaar to come back and then go into the pricing. Rather, you spread this, execute it parallelly. Then, before you go back to the client, of course, you have to come back and then make it together and so on. So, your design concepts have to follow this discipline. Like, for example, various things are written here. If you see, right, one is a domain driven design, that is, you make the boundary of the domain very clear. Solid principle. So solid principle, if you look in the Google or if you read about it, it's very important. You have to surely understand what is solid principle. It is nothing but the responsibility segregation. Okay, solid means you are developing a component called calculate pricing that will have a clear boundary of the functionality. To some extent, what we talked about in the domain driven design, it will also have a clear interface for somebody to consume. So you are saying, I will handle the pricing if you invoke my interface and give me these details. So that is what the interface definition in object oriented means, right? You are telling others that I need to get these details from you. You invoke this method, passing this, I will give you back this. So that's clearly what it is, right? It is like a product saying that I will give you this if you pay me this. So exactly that. So clear cut, this one. And also, there is no, and every service, every request is separate request, so there is no chaining or nothing, because, right, one, every call is independent of each other. That's another thing in solid principle. So these are all clear mandates of a solid design, and that allows you to enable your services to be deployed independently. You can scale. For example, if you see that after putting this service in live for 10 days, if you see that lot of calls are coming, or the maximum time spent for the services, the claim and the calculate, means you will be able to scale those two alone much more, because you can go to the cloud service. If it is in a container Kubernetes which is running, you can increase the number of clusters there. Or if it is a web app service running, you can increase the number of CPUs. Or if it is running on a machine itself, on your cloud, which is the VMs or whatever what we call, increase that capacity. You understand, right? That's a great. And because you are not doing any state management, there is no coupling, there is nothing. Every call is independent. This only deals with pricing. You know only about pricing, and you are, as long as you get what you are asking for, you give what you guarantee. That's the simple layman term of these concepts of solid and so on. Dependency injection is another new concept. So dependency injection is nothing but when you run a concept, a particular domain, right, what dependency that need. For example, when you are running a pricing calculation, you may have a dependency on a pricing service or a database connection, because you may have to go to the database. For example, if the person is 60 years of age or above, or a senior citizen, you have to go to the database and get the rate for that senior citizen. So that's one dependency. So the good thing is, like, unlike in the past where you hard code and build everything together, right, here you can actually make the dependency configurable. So that, right, when you run the pricing calculator in Azure, for example, let's say you are using Azure Cloud, then the dependency can be easily mentioned that I have an Azure database or a MongoDB database sitting in this. It will wire up that automatically. I mean, the technical implementation of that I'm not getting in, but just take these concepts as it is and just go and read about it. Independently deployable, we said, fine grained. That's very important. So services generally, when you look at the service design, right, it will have two concepts called fine grained versus coarse grained, right? So why that is important again is, fine grained means it is the lowest level. Get employee details is fine grained. Wherein get employee, yeah. So get employee details is fine grained because it only gives you employees details. But the get employee and department details is coarse grained because you are asking it to give more than one domain back as an answer. So it's all, when you do that, it is not a problem if the requirement asks for, but then you have to imagine you cannot scale it yourselves. Because when you say get employee and department back, you can scale employee side which you are owning, but you have to also depend on the department guys to scale up that service. Otherwise, what will happen? The service again will have a bottleneck. So these are the general high level concepts. I'm also going to briefly introduce few other things as well to you after this, taking you through this 2 minutes. So again, this I will not spend much time. Just these are all concepts around uh, uh, what do you call? See, singleton, static. They are all object-oriented concepts, isn't it? So singleton, factory, those type of patterns are very popular when it comes to this layering and the service invocation, because what it ensures is, right, you have only one way of initiating a service. So, for example, I'm putting a service called pricing calculator, and some I'm also offering an interface. There will be a I interface for that pricing calculator, as you would have done in Java or in the what do you call C++. I am also expecting the consumer of it to consume it only through that interface, and only through one way of initiating me. When I say one way of initiating me is, imagine the consumer here is the layer above, right? The website, right? Imagine this website is consuming my pricing calculator. I would expect that website always to come through a single factory method to initiate me. The advantage is, right, then the if I have to manage the connection pooling, or if I have to manage the instance pooling, all those I will be able to easily manage it. Wherein from the same application, if you call initiate me in 5 different ways from 5 different places, then the traceability or the management side of that component is little difficult. So these are neat patterns. The otherwise also it will work, but the singleton is like that, and singleton also is much better ensured through a factory. So basically in your client code you will write a factory method, and through the factory method you create the instance of that interface and then invoke that method called employee or whatever. The advantage is, right, as you can see, there are many advantages. For example, if it is an override ridden method, it has advantage. You can also create test instances. For example, instead of the real instance, if you want to create a small factory for inject a test into it, you can easily do through the factory. You can actually control the behavior of that service invocation if it is done through a factory, because it's in one place. It actually looks at the configuration in one place, so you can control at a central place rather than having 5 different places. And this factory pattern is also a clean way of implementing the dependency injection. So for example, if dependency is injection that framework is used, what happens is, right, as I said, before even invoking that pricing calculator, you are putting a dependency, you are passing a dependency saying that this need a dependency of another component or a backend or something. So because it is in factory mode, and factory is a single place, singleton way of doing it, and then in a central place you will be able to control the dependency as well. So these are all some sanity need patterns used. Strategy pattern is for another concept. You would have heard about many of the applications used in more than one country and in one language, right? So, for example, if you have an application pricing calculator running for UK and another client is running, so for example, I'm just giving you a very high level thought about all these things. You want to get into that. Next half an hour we'll spend on little bit cloud enabled scalability features and one case study. So, for example, right, if these applications are running in more than one language or deployed in more than one country, it may still come to the same one central service, right? But it may pass a country parameter or something, so that you know that okay, this is ran for UK, or this is ran for Norway. And of course, your component need to handle the different country logic. So, for example, for UK, the rate will be different. The Norway, the rate will be different. So, our standard, very basic concept is to use if conditions, etc. in the code. If country equal to UK, do this. If country equal to Norway, do this. But that's not how enterprise systems are built. Again, you note this down, you can actually do wonders with it. So, for example, if you read about strategy pattern, this is largely replacing that if else case type of a condition, because if else and case, right, if you start putting in an application for every country, if UK, if Norway, imagine if a third country comes, it will be utter confusion and the code is not maintainable. Somebody new coming into it will get standard. So what people normally do is they will create a base country class, like typical our object oriented concept base country class, and then you create an overridden country for UK or Europe, right? So that see German or Sweden or Norway country. So what will happen? The common things will run from the country base class. If something is very different for German, it will invoke the German class, because through the dependency, we will tell that we are running this function, this particular call we are running for the context of Germany. That's the dependency we are injecting through the factory, right? And then what happens when it comes to the code? So basically, right, when you invoke from here, we are adding any dependency injection saying that you are running this for a German scenario. All the way it comes, it knows that okay, you're running for German scenario, may have to look at different rate card, etc. But then in this, you don't have a if condition or anything. What it does is it will first look at the base class of country, see whether the rate card is that, but you know that is for German. There is an override class for German, and it will invoke that. So these are certain neat enterprise practices which are followed. But you don't have to worry about these things when you're writing a small hackathon type of an application. This is for your real design thinking. So again, you can see there are so many different ways of shredding and splitting applications. And again, we didn't talk about the database layer, but database layer also you can split. But generally, database layer, if you split, the thinking is that it increases the response time and all that. So you have to carefully do the domain splitting in the database. For example, if you split a people database, let's say everything to do with the people, which is employee salary, everything into different database called employee salary department, then actually what happens is the intra processing, this dependency processing will increase multifold. So you have to always weigh that which one is better, and you have to do it accordingly. There are many more scalable patterns available. I'll just introduce some terminologies into you so that you can think about it. See, we are on now. So far, we have been talking about a very straight through processing type of a thing, wherein a website clicks a button, it invokes a service. That service invokes a sub service, subdomain, and that subdomain based on the dependency, it will invoke the further things like and go to the deep database and get back and so on, right? This is a standard thing we did. Yes, that is true for 90% of scenario, but there are scenarios which we also said that it could do parallel processing by doing a parallel Aadhaar call and then coming back. So there are patterns around asynchronous invocation in such cases. Not everything can be done asynchronous, but there are cases where you can do things asynchronously. We are also I didn't want to leave this green layer, but I'll just introduce this. So this API gateway is again a standard service, which actually is a abstraction. So for example, whatever happens to the right side of it, the left side don't have to do. So if you want the create pricing functional to be named as get pricing, you can abstract it by giving a configuration here. Or if you want to, you know, let's say this need 10 parameters to be invoked while invoking, but the front end will pass only 5 parameters and rest is hard coded. You can do all that here. You can do security token management here. So when the client or the front end calls, it has to call with a auth token or a security. It comes all the way till here. This will recognize that there's a valid token, and then the standard call goes to the backend. These are typical gateway functions. Monitoring. It can actually create logs and reports and monitor and see how many calls are coming from your German portal, how many from the London portal, and so on. Though many things are achievable here, is nothing but an abstraction layer, which will ensure that separation of this thing. Again, it can scale as well. There are aspects like caching as well, which is caching and CDN, for example. Again, you instead of going all the way to the backend and getting it, it can be cached at the front end layer, at the middle layer in the API gateway, or even at the service level as well. So it could be cached for a time, till a time, or till the next update even happens. So those kind of things are possible. Right. CDN is again another way of caching the master data in the nearest geographical location. So let's say the portal is running accessed mainly from UK, right? And you are hosting this microservice and database in India, for example, right? So what happens is when somebody in UK hits this website first time in his browser, it has to bring all the images, all the things all the way from our data center in India to UK, right? For every different user, it has to do it. But the advantage with CDN is it is a cache defined in the nearby geolocation. So there are CDN services for cloud and other things. So for example, what happens with CDN is the static and heavy images and all that you can cache it in the CDN in the UK somewhere itself. If you buy, Redis cache or various CDN services are there. The advantage is that the people who are accessing the sites will see a very good experience because it downloads straight away into there this thing, and it doesn't have to go there. And the CDN will be refreshed on, as I said, on a timely basis, weekends or whatever. So that is another way of scaling. Then there is this event driven thing I wanted to explain you after this. I'll try to stick to my time. So this is one way of now, as I said, layering has gone into domain and subdomain, and services. Normal web services have become microservices now, right? This microservice is nothing but following a solid principle, following that segregation concept, right? It is only trying to do what it has to do, or the name suggests. Let's say pricing means only pricing, employee means only employee. If pricing for an employee is required, two microservices are to. That is how the concept is. So the advantage is that this has the ability of deploying on this, and independent, totally independent. So if you look at this microservice one, for example, here if you see it's CRUD only. For example, create piracy, get the rate, save the price. CRUD means create, update, delete, right? If you get into the microservice 2 here, right? Here, this is probably for a complicated scenario like claim. So you can see it has a little different technology written. I will just briefly talk about it. DDDD, we already said, it's a domain driven design. So imagine for claim, it only handles claim. But there is a concept called CQRS written in this. This is very important. I want to introduce that through this pattern slide. CQRS is, so again, this I think we have already spoken. Traditional architecture, it has been now layering, sub-layering. Even in the database, you can see this is on another layer, right? So this here I wanted to show you another brilliant innovation or another new way of doing solutions, a scalable solution. So basically, right, you just see the slides. As you can see, CQRS is nothing but command query responsibility. I've already told you that in the past, all our scalability constraints was due to the database logs and things not able to concurrently update in the database when multiple users are coming. When we retrieve it, it used to give wrong data due to logs and things like that. So, because whatever you do in the middle layer, to some extent, unless there is a database dependency there, it will go to that level, right? So, here, what people have started using is, right? If you look at the IRCTC type solutions, right, wherein lot of search happens. Imagine all that search happens on the main database. That search itself will create a lot of performance problem, even if you have tuned the query, even if you have created the indexing and all that. So one quick way of enabling the lookup fast, because if you see IRCTC, the lookup is the main thing. The data, what people do 10 lookups to do one booking, isn't it? Or 100 to 10, something like that. So what happens if you can make the lookup not affecting our main DB, we have won the battle. So that is the design thinking behind this CQRS. We are actually responsibility segregation we are doing, which means we are splitting between read and write. So one way to do is you create another DB, separate database which is synchronized probably in 5 minutes, and then you make all the searches and read to happen to that read only database. Let the backend update happen to another database. That's a simple plain thinking of anybody, right? And that is what it is, okay, to some extent. So basically we are now uh, making a system in such a way that, right, the read is very fast, write goes through the typical flow, and we will make the read and write, there is a small gap of few minutes or seconds. For example, if you edited a data, for that to appear in your search or in the read, it may take few minutes. So if that is allowed, then the CQRS is the best solution. If you can see, right, very simple, from the IRCTC, all the searches coming through a very quick layer, and it will take and retrieve from the read database. And for the read databases, there are new technologies also which has come. So we were all the while till last 4 5 years, we were worrying only about SQL Server, Oracle, RDBMS, the what is that, the database concepts, ACID properties, all normalization, all that we were just saying, right? But now, if you look at the cloud and the scalable architecture and solutions, is people have started talking about NoSQL database. And no more talking about RDBMS here. We started talking about MongoDB, which is a famous NoSQL DB. RDS, Cosmos, there's so many in the past, in the recent past. So the advantage is they are not RDBMS or relational databases. They are databases which will store records as records, either as a JSON or as a object or as a document. Many different technologies are there. The advantage is to make the read fast. Write is slow with NoSQL. Surely. That is why people still use RDBMS for the main transaction database or the write database. For read, NoSQL is fast. So here if you see IRCTC, transactions always come through a event based thing onto a onto a proper RDBMS OLTP database. What we call in the past is OLTP, right? Which is nothing but the transaction database. Then in few minutes, once an update is done here, maybe we have a notification or a event system which will raise an event that will create an entry into the NoSQL read database. Because here people are hitting this massively for the lookup, for the search, the train timing update, all that is happening here. So imagine the minute by minute or station by station update typically happens on a event, like as the train passes through every station, an event is raised through a queue based system. Even bus is nothing but a queue. So you put that into a queue, first in first out basis. It is taken and updated to a read database like this. Immediately there are people sitting on the mobile and continuously searching, right? For example, if you are traveling, your parents will be searching all the time till you reach the destination. See, if you are traveling a train from 8 a.m. to 10 p.m., right, your father or parents will start searching from yesterday until you reach. So that is how it is. So the read has to be fast. So this is a very important pattern. Keep this in mind. Here we have introduced many concepts like the even bus based. Even bus is nothing but a team. Uh, when update happens on your back end, right, we have this notification services type architecture in various cloud and things like that. Or you simply write a small program to every minute check that and raise a message queue are very important part of the current architecture. Queue based systems or message queue or even bus are all same. They are part of the current cloud based architecture. So based on your update, you put a message queue. On the message queue, there will be a listener which will read that and update the read database. So in split seconds, as the train passes the station, update is going back. So this is one concept I want to introduce to you, and then so on, right? All the other things I don't. Yeah, we have talked about MongoDB and so on and so forth. So I think, and then we also spoke about the container aspects as we cover in the bottom. So container is nothing but the way you package a service and the way you deploy onto the cloud or onto your local container. Don't think that it is only a cloud-based deployment. No, you can have a container. So once you develop your program, right, you can create a Docker container, which is one of the most popular one, and put it into the Docker repository, Docker hub. From there, you can actually deploy either by running directly the Docker solution, or you can deploy using the hosting services like Kubernetes. So you can simply say that take this Docker, run 10 instances there, and then if more than more request comes, spin up more. So those kinds, because eventually your cloud billing will go up, but then the scalability is there. So I think we have touch base these things: DDD, CQRS, domain events. Domain events is what I was saying. Passing of every station is a train status update event, right? So how you implement? There are various ways. Like you can either build a listener, or you can actually use a cloud notification service to do that. Yeah. So basically, you can see every database. So if you are talking about a microservice called, pricing calculator, we spoke about splitting that into subdomain, and even the database, if you want, you can have different databases. For example, as is shown in the diagram, it could have a claim read only snapshot database. It is a snapshot, right? Because the real claim data is sitting in the transaction, DVR, DBMS. You can create a small snapshot which is going to help the people who are searching or reading quickly. Could be a NoSQL or whatever. Again, we spoke about solid principle independency and no chaining, etc. So that is what you will see concepts like stateless, for example. Stateless is nothing but I am calling one service now. You are calling in next minute. Between your call and my call, there is no state manager at all. unless some master data, standard rates, or whatever you want, you can do the caching. That is what is written here. Okay. So microservice, all those things are, so now when you are accessing a website which is built in Angular or Vue or React, basically that, imagine if you are accessing a page called claim, you can very well assume that that is a micro app, or that screen will be calling a microservice called claim microservice sitting behind it. It will have its own caching, it will have its own server, everything will be its own for the claim. You are passing a dependency that I am asking for a claim for Germany policy. So the claim knows that, okay, you're asking for Germany, I have to go to the German server or the DB to get the German claim details and give it back to you all the way. So that is how you want to be separate. The another advantage is security. Security is a whole together different topic, cyber security, right? When it comes into this type of a solutioning, cyber security is very important. So what happens is, right, for example, different, we already said we can have, I'll take next 15 minutes for the case study. We can have different microservice for claim and all that, right? Imagine one service, for example, your policy service is much need to be much more secure. You don't want to expose the policy service the same way you expose rate, because claim service will be, or policy service will have the personal information, PII data, which is not supposed to be shared. So what happens? The security of this microservice one has to be totally different than microservice two. It may need a authentication token to be passed, and you have to validate whether the person passing the token is existing and is allowed to invoke you or not. You understand, right? Those kind of concepts are available. That's again very good with microservice, because at each domain level you can have different security possible, caching possible, navigation possible, different type of logging, monitoring. You can actually create a report and say that how many German claims hit came today. Everything is possible because you have the minute level of granularity there. Got it? So yeah, so typically this is how we do this. We start with a 2 weeks discovery to understand the high level requirement. Then we go on and then create an MVP, which is what you call as POC, or what you develop in a hackathon, right? So in a hackathon scenario, you may not have to go through all these things, but if you know this, it will be very very useful, because these concepts is not new when it comes to AI as well, right? When it comes to a RAG solution, when it comes to a, see, databases are all same. Only thing is that it will have a new column type called vector DB, right? The way microservices are all still same. Only thing, in the microservice, instead of database, it may be invoking an LLM, but that service has to be scaled up. LLM has to run on a bigger compute with GPU machines instead of CPU. So, but the logging, the security, everything remains the same. The client layer, instead of being a simple thick client or whatever, now it may become a chat layer. That's only different. So, very important concepts. It is important to know these things in your day-to-day thing here onwards. And I will just briefly talk about a case study as well, what we have done. Again, this is done for a very large customer. We have done for a large customer in Europe, I think. If you look at the layer, right, if you look at the simple layering of it in context to what we discussed, you see the number of layers. Earlier it would have been only the leftmost three layers, which is online, which is the apps and the integration and the offline. Now you can see every layer is sub split into it. So we have the front end application at the client. Some of them are thick clients, some of them are the Angular app. Then it comes to a API layer, which is application service layer, because that is where we want to scale up the number of calls, do caching, and things like that. Then we also have integration services. Integration services are nothing but, we already spoke about, invoking different domains within itself. For example, if you want to run a policy quotation, you have to invoke pricing, because you have to get the pricing for the quotation. You also have to check whether the person requesting is genuine by calling the other service. So that is integration service. There are tools available for it. You have tools like API gateway and all that. Simply it will do a parallel call, and the integration service will ensure it returns only after all the calls are correctly returned. Or you can configure the way it has to return, whether asynchronous, partial returning of that result. And then again, you come down, you see the data, layer split into domain, customer is different, policy is different, claims is different, so on. Underneath, again, you can see in customer itself, here it is showing one box, but we already said in today's world, there may be a customer OLTP or the transaction database, and there may be a customer read only database, which may be in Mongo or whatever, because there are many customer searches happening just to improve that performance. So that is very that is at a high level. And again, this is an enterprise view. For example, if this was mainly from an application view, this was from one application view called claims. This is a cross-functional view of the whole, what do you call, enterprise, wherein, as I said, there is a front office system, there is a back office system, people system, and it is all intralinked. One application may navigate to the other, one application may call the functionality of the other application's domain using a properly defined interface, and so on. So again, the concepts of object orientation, again, the whole architecture may repeat again because it may be used from two countries, and that is where the country dependency has to be passed all the way from the front end to the back end, so that when we return, we know which back service we have to invoke. Again, this is a cross-sectional view of it. Look, can you be mute? I think request everybody to go on mute, please. Yeah. So this is again certain. I'll just play it for you. So pattern view, again. Most of it we have covered. The strategy pattern for different countries, the service pattern, the factory pattern, the singleton pattern. All those things we have actually covered. I will in last 7 minutes. I will also take you through a typical cloud-based as well. For example, right? I'm sure Joby last session would have taken that, but I think I just wanted to tell you, for example, when you superimpose all these things onto a cloud, right? What happens? Yeah. So I mean, just to talk about it, few services and things like that, which to summarize your understanding. Yeah. So basically, yeah. So again, we haven't probably gone into the theory, but this is the cross functionality, or what we call as cross-cutting concerns, which anybody expects in a when you're defining or designing a system. This is the definition of the quality of an application. People call it as non-functional requirements, wherein availability, scalability, maintainability, all these are illabilities, but then these are very important, right, when it comes to a solution design. Yeah, and so basically, right, I just want to superimpose something on this. I mean, a typical yeah. If you talk about a cloud-based system, again, now coming into taking Azure as an example, right? What happens is, right, when you comes into an Azure environment, you can assume pretty much it's like a data center where you have your own account level isolation, you will have your own Active Directory, you will have your own VNet, and then you will have subnets for different layers, right? Like the claim department will have its own VNet or subnet. Typically, VNet isolation will be there in different departments. Then you have common functionality services, or the SaaS or PaaS services, like the storage, Azure Storage, or if it is Amazon, it's S3 bucket. and then the services like the Kubernetes and other things, and all the other security architecture. So without going into the details of this thing, right, if we just talk about some of the scalability aspects of this, or the components related to scalability, I will only touch upon that, because there are so much and so many when it comes to cloud. If you look at the scalability aspects, we already spoke about the event driven design, the messaging architecture, and that is where you can see the third line, which is very important, which is the serverless based of computing. That is another new way of computing in, which probably you are more aware because you have started recently. You are more using these things like the serverless aspects, right? They are just in time invocation services. We are not paying required to pay the full service compute money. For example, if you deploy a service onto a server, you don't need to pay it for the deployment time, deployed time. Rather, you only pay for the time it is running. For example, Lambda is one of the most popular Amazon service wherein we typically deploy our functionalities, right? So it may be triggered based on a file arrival or some click of a button, wherein it is exposed as a service and so on. So it will only charge for the compute, what it for the seconds or whatever it runs, and the number of instances. The advantage is that it can scale big because it's serverless, it's managed by the cloud vendor. When it is a server based hosting, the difference is it is managed by us. Even if the server is sitting on the cloud, because you are managing it, you are load balancing it, you have limitations in scaling up and so on, or you have to take care of that load balancer and the routing. Wherein serverless components like Lambda, SNS, all that is auto scale managed by them. Rarely it will go to a limit if you configure it rightly. The fourth item is the thing which we already said about Kubernetes, most popular container platform wherein you simply can mention the container and the host and it will start spinning up the number of requests for you, the load balancing, the traffic management, everything is taken by the service by itself. Again, you can have Kubernetes based on the self-hosted model, server model, where you create a VM and you put the Kubernetes service by yourself and creating the cluster and all that. But then what happens is you will have to manage that virtual machine and things like that. So the management of that scalability become your headache, but the payment is less. So depends on your functionality what you're building, right? So these are very important. We also spoke about the queue-based services, the things like SNS, SQS, SNS, XQS are Amazon's queue-based services. There are similar ones for Azure. Even bus is another thing. So all these are basically things wherein it works on a concept called publish subscribe. All queues works like that. That is, you are saying that I will publish a message in this format. I'll put it in the queue. Now, it can have one or more subscribers to it. So you are the publisher. You are saying I'll put a message like this. If 100 subscribers are there who are subscribing to that same message structure, they all will get the same thing there. You got it right. So you may put a message saying that the station has crossed Kochi. There could be 10 different subscribers or listeners for that message. There could be one listener which will update the read database and say that this train Vande Bharat has passed Kochi. There could be another service which will be listening to that and it may update some third party service like Make My Trip or something as well. So all gets the same message. That's the concept of public subscribe. And first in, first out basis. Yeah, then I believe that's mainly what I would like to cover. Of course, the security aspects is a big thing, ring fencing, all that will come in when it goes to cloud. I think we have largely covered it. Yeah. The last but the not least is this data side of things. Data side, I know we have only briefly touched about database and the NoSQL aspect of it. that is only one part of the data management, right? But right, and there are now concepts like uh, unstructured data, for example, right? See, we talk about a database saving of a train record or whatever, or OLTP or RDBMS or NoSQL. Everything has a structure, whatever it is, right? So, which means if you have a table, all the data will have the same structure, almost predictable. Wherein unstructured data is not like that. It's like the log data. It's like one data will have 5 lines, next data will have 2 lines. So that is where the data growth is going on significantly. Significantly, it is uh, significantly, it is growing fast with the, especially with the AI coming in. There are so many tools coming in, and they are very good in reading this unstructured data, summarizing it. That's the main thing what people are doing AI. So there are a lot of technologies in that, we have not got into it. That's a totally different ball game, right? It is a powerful area, but the data science, the data engineering, the unstructured data storage, the discovery of that possibilities about AI, all that is a different ballgame. So once again, thank you. I will open for questions and then we will wind it up. So this is what I have planned for you. I hope it was useful. I tried to go as fast as I can so that I could share more with you. Yeah, that's it. Yeah, questions, please, if any. Hello, Ashish.
Hello.
Hello. Yeah.
Yeah, guys, if you have any question related to today's session, then you may ask.
I think they have to go back and refresh many of the concepts. I tried pushing in maximum I can in the last 1.5 hours. So I hope it was useful. So Ashish, then shall we call it out, Ashish? Or
Okay, sir, we are closing the session. Uh,
thank you so much.
Thank you everyone for
Hope
your
it
active
was useful.
participation. And a special thank to our trainer Sri Krishna Kumarji for sharing valuable knowledge and guidance and made this session wonderful. We wish all SIH 2025 participants that very best for your journey and innovation. So we are closing the session now. Have a great day ahead.
Thank you. All the best, guys. Rock the hackathon. Thank you. Bye. Okay, Ashish.